All right, so we're still working on the spread, and we're going to do an example here. We are in a quality control test of 2 laboratories, where each were given 20 caloric soybean leaves, where it was known that 50% of a protein compared to normal soybean leaf. So each leaf given to them, so this represents 20 leaves, and the sample that's given, the researchers know that each leaf has 50% of the protein compared to normal soybean leaf. The results are shown on the histogram, for one for the black lab and one for the purple lab. Which lab would you use to test the protein content? Well, when I first look at the black lab here, what I can see is that it is fairly symmetric, maybe a slight skew to the left, but it's fairly symmetric, with the mean or median going to be about 50, 51, 52 in here, which is really close to the actual 50% that is given. The range of the black data is from 65 to 35, so if I subtract those, I get a value of 30. If I look at the purple lab, I can see that again here, when I look at this, it's fairly symmetric. The mean is also here in the middle, about 51 or 52 in here. But the range is much larger. It goes from 30 to 75. So if I subtract those, that is a range of 45. Well, what does the standard deviation do? When I quickly look at them, I can see that these 20 values are far more compact and more consistent than the purple values. Yet the center looks to be about the same. And I'm really trying to address which would you choose to be the protein content. But let's talk about the standard deviation, which we haven't really done much. Like the range is quite easy to see, but what does a standard deviation, what would it be in these cases? So if we consider these, let's talk about the standard deviation. In general, a definition for standard deviation is this. It's a measure of spread that is the typical or average value away from the mean. So in our 20 samples here, we get a sample, we measure it, and the mean is about 50. So how far away would you expect that value to be? We know we're not going to get 50 all the time, but what's the average value away from the 50%? Maybe it's 48%, maybe it's 54%, but there's a value that you're about that far away from the mean. And that is what standard deviation measures. But another part that adds to the story of standard deviation is this. If I had this perfectly normal curve, this bell curve, it's called, the normal curve, I know that if this is the mean, 0, and this is 1, here is 68% of all the data points fall within 1 standard deviation away on each side. So the middle 2 standard deviations are 68% of the data. So the cluster of it falls in here. And so 1 standard deviation consists of about 34% of the data. 1 standard deviation is 34% of the data. And so the calculation for standard deviation, we're always going to do with a GDC or with a computer. We're not going to do it by hand. But it's always good to get a ballpark figure. And one estimate that exists for the standard deviation is if you take the range of the numbers and divide it by 4, you'll actually get a pretty reasonable estimate of the standard deviation. And then finally, as I said before, the variance is just going to be the standard deviation, which we'll call S. It's just going to be S squared. And that's it as for the variance. But let's go back. If this is our estimate for the range, or for the standard deviation, we could get a pretty good sense of the standard deviations here. So if I'm going to take 30 and divide it by 4, I get 7.5 is my estimate for the standard deviation here. And if I do it for the purple graph, 45 is my range. So if I go 45 and I divide it by 4, I get 11.25. So 11.25 is my standard deviation. And so the spread of these numbers is much more than the spread of the black lab. If we were actually going to do it for real and find the standard deviation, I can see that the black standard deviation is 5.1 and the purple standard deviation is 9.8. So 9.8 and 5.1, it's close enough to give us a ballpark sense of what's going on in this data. So let's continue further. So there's our standard deviation. Let's go even further. And here are the box plots, which you saw on the graph. And the IQR for the black ones, if we estimate this, is going to be about 49.5. So 49.5 is quartile 1, and 53 is the third quartile. And so if I subtract those, I get 4.5 is the interquartile range. And for the purple, it goes from 40 to 55, so that is an interquartile range of 15. So again, the spread of all of these are much larger. But here's another important thing. Here, the median is 51 versus 50. And if I'm trying to answer the question, which lab would I want to test my protein content in? Well, the black lab has a median of 51, where I know each leaf was 50%, and the purple lab had a median of 50. So the center of this one is more accurate than the center of this. But if I was going to choose a lab, I would choose the black. Even though the median is higher, they are more consistent in getting the right value for the proteins. Their spread is 7.5 versus 11.25. They are more consistent in their analysis. There's more variation in the purple, and if I'm going to try and get accurate measurements for my laboratory, I want consistency. I want a small standard deviation. And so even though they tend to be a little bit high, this, I believe, can be calibrated by the machines, whereas this looks like sloppy laboratory work, and the consistency comes here in the black graph. And so we use not just the center, but we use the spread to analyze the data, get a sense of what's going on, whether it's the range, the standard deviation, or the IQR that you can see here. And so the black one is far more consistent. That's the lab to go to.